So, hello everyone. I hope you're doing well, and welcome to this first workshop series on artificial intelligence. So, this workshop comprises three main courses related to the data science field. The first one is an introduction to machine learning. Second one is an introduction to deep learning, and finally, introduction to data visualization. Of course, today we're going to start with the first one. But before we dive into the course, allow me to introduce myself. So, my name is Abdelghafour HALIMI. I have a PhD in image processing and artificial intelligence from the National Polytechnic Institute of Toulouse in France. And I was working for the last 5 years as data scientist for the company Atos in France. And I just recently joined the Chaos Visualization Core Lab. So our Core Lab provides a lot of facilities and expertise in various fields. For example, my colleagues James and Thomas are specialized in 3D data visualization using Viselt and ParaView. My colleague Ronel is specialized in virtual reality and augmented reality using Aviso and Unity. And me and my colleague Didier are specialized, who are going to assist me, by the way, in this course. We are specialized in the data science field. And finally, our manager, Sohaib, who is specialized on creating advanced dashboards using advanced visualization tools, is managing also the administrative stuff. So don't hesitate to contact us. I'll put you a link here for our wiki page, where you can find more details and the information about the different services that we are providing. We have also a YouTube channel that you can check, where you can find the previous tutorials and training provided by my colleagues. Okay, all right, let's start from the top. What is machine learning? Machine learning is a very broad field, and it contains many different aspects, and you're gonna see a lot of definition of it online. But for the sake of this course, we're gonna try to keep it as much as possible practical. So in a single sentence, machine learning is using an algorithm or computer program in order to learn some patterns in the data, and then using that algorithm and what it's learned in order to make some prediction on the future on similar new data. Now, machine learning algorithms are also called models. We're gonna use this term a lot later in the Jupyter Notebook examples. But you can ask how then a machine learning algorithm differ from a normal algorithm or computer program. The answer is the learning aspects. Let's see an example. Now, where a normal algorithm could be, for example, a set of instructions on how to turn a pile of raw ingredients into your favorite chicken dish. So the first instruction could be cut in the vegetables, then season the chicken, then preheat the oven, etc. And if you follow these instructions correctly, you will end up by having your chicken dish. Now, what's important to note here is that a normal algorithm is going to start with an input, which is the ingredient here, and a set of instructions in order to get the output. Machine learning is different. Machine learning algorithms are going to start with an input and an ideal output in order to, and you're going to try to figure out the right instructions. Now, think about it. It may be not going to work for your first try. You're going to put a lot of spices. Same thing for the second try. You're going to put some extra spice. Third try, still not working, but you start getting closer. Now, when it comes to machine learning, this process can take hundreds of tries and iteration. We call this epochs. And at some point, the algorithm is going to converge, and then you're going to find the right instructions. So now, I know that I'm missing and skipping a lot of mathematical details behind this, but this is just a simple way to give you an idea about how machine learning works. So keep in mind, you're going to start with an input, ideal output, try to find and learn some patterns, create some relationship between these two in order to find the right instructions. And next time, maybe when you're going to have some ingredients in your fridge and you don't deal with it, this algorithm could help you by giving you some ideas on the dishes that you can make. Now, what's the difference between data analysis and data science? Data analysis is trying to gain some understanding of the data by comparing different examples, different features, by comparing different visualization like graphs, histograms, pie chart. On the other hand, data science is taking this step further by doing a lot of experimentation on the data in order to gain some insight within it. One of the experiments that you can do is building a machine learning model. So as you can see, data analysis and machine learning are part of the data science fields. Now, what we're going to try to cover today. As I said, I'm not going to enter into the mathematical details, statistics behind the machine learning models. What you're going to do is try to keep it as much as possible practical, which means going through the different steps that you can find in a real machine learning project. And you're going to try to build a pipeline or framework that you can use maybe later for your own problem and adapt it for your own problem. Now, here I try to summarize the most important step that you can find in machine learning projects. Machine learning comes in three main parts. The first one is data collection, then data modeling, and finally deployment. Data collection is when you try to get the data. It means by downloading it from servers, cloud, doing web scraping, for example. Deployment is how you're going to share your application, maybe by building API or creating dashboards. And finally, the most important part, which is data modeling, and which we'll be focusing on this course. And we're going to try to go through these different steps deeply, from problem definition, data, evaluation, features, modeling, and finally experiments. Let's start with the first one, problem definition. What problem are we trying to resolve? Now, before we go in and see the different main type of machine learning problems, I need you to know that machine learning is not a solution to every problem. And it's not the best choice always. And you should know when you shouldn't use machine learning first. If simple hand-coded instructions-based system work, go for it. Forget about machine learning. This is the best solution that you can have. For example, if we have already the instruction to create our chicken dish, this is the best model that you can have. Machine learning is going to be a waste of time. Don't do it. On any other kind of scenarios, it's going to be very helpful and useful to use it. Now we're going to start project. You're going to have a business problem, and you're going to need to match it to a machine learning problem. Here, these are the main type of machine learning problems: supervised learning, unsupervised learning, transfer learning, and finally, reinforcement learning. Now, supervised learning is when you're going to have the data and the labels. And the algorithm going to try to predict the labels. And if he gets it wrong, he's going to correct himself. This act of correction is why it's called supervised learning. Now, supervised learning has two main type of different problems, inverse problems, either a classification problem or a regression problem. Classification is when you're going to try to predict either something is one thing or another. For example, if someone going to have heart disease or not. This is called binary classification. If there are more than two options, it's going to call multi-class classification. For example, predicting dog breeds or different car types. Regression is when you're going to try to predict a number. For example, how much will this house cost based on the area, number of rooms, number of bathrooms, for example, or how many people will buy this app based on the advertisement, services, the website, for example. Next is the unsupervised learning. Now imagine you have the purchase history of all your customers at your store, and the marketing team is asking you to send a promotion for the summer. Now you know that not everyone is going to be interested on this. So you decide to run machine learning algorithm, a clustering one, by the way. We're going to try to group all the people that are going to purchase similar things. And you're going to find that there are two groups of people. People who purchase only on summertime and people who purchase only on winter time. Now, you can target only the people who purchase on summertime for the promotion. This is unsupervised learning. Supervised learning is when you're going to have the data and you don't have the labels. And the machine learning are going to give you the labels, predict the labels. Next one is transfer learning. Transfer learning is when you're going to use what the model has already learned in one domain to help you in another one. For example, from this image, you want to predict the dog breeds. You're going to use already pre-trained model who already learned how to differentiate different car types and then tune it and adapt it for your own problems. Now, why is it valuable? When you're going to start doing machine learning and build a lot of model trying to do a lot of training on them, you're going to see that it's an expensive task, which means each machine learning model going to do millions of calculations. And these calculations sometimes aren't free. You need to pay for that. So it's going to cost you a lot in time and a lot in money. So instead of going from scratch and learning what an image is and the different patterns that is in an image, you're going to use a pre-trained model to help you with it. And it's going to save you a lot of time and a lot of money. This is very interesting and valuable. Yeah, why transfer learning is valuable. Next one is reinforcement learning. Reinforcement learning is when your machine learning model going to do some action, and you're going to reward it for doing it well and punishing it for doing it bad. A good example is to teach machine learning model how to play chess. The best one till now is the very known one is the DeepMind AlphaGo. And these kind of programs are very used for video games. Okay, so keep in mind, remember always how to match your business problem with a machine learning problem. If it's supervised learning, you should know, I know my inputs and outputs, and I'm going to do the correction by itself. If it's unsupervised learning, I'm not sure of the output, but I have the inputs. Transfer learning, I think my problem may be similar to something else. Okay, so next one, data. What kind of data do we have? Now, there are two different types of data, either structured one or unstructured. Structured is, for example, Excel files, CSV files, tables, data frame. Unstructured one are like images, audio files, text, like emails. Now, these two types of data can be either static or streaming. Static means when the data are not going to change over time. It's going to be static. For example, if we have the medical patient record as a CSV of patient, you have these different parameters as a CSV. It's not going to change over time. I mean, it's going to be static. And the more data do we have, the better. The other one is streaming data. Streaming data means it's changing over time always. An example is stock market price, or maybe time series data for dioxide carbon. This is very used to do forecasting and to do monitoring. Now, this is common, for example, common data science workflow. You're going to take your static data as a CSV, create your environment using Jupyter Notebook, then convert this type of data into a data frame using some libraries like Panda, do some data analysis, build in a machine learning model in order to detect if someone's going to have heart disease or not. Next one is evaluation. Now, what defines success for us? And what kind of metrics are we going to use to measure the performance of our machine learning model? When you're going to start a project, you need first to set a goal. For example, for this project to be worth pursuing further, we need a machine learning model with over 99% accuracy. So if you have any score under this, it's not worth pursuing. Change the model. Same thing for classifying car insurance claims. Is it his fault or not? If it's under 95%, change the model. What I mean here is that every time you're going to start a project, you need to fix a goal, to set a goal. And these are the different metrics that you're going to use for two different problems. I choose here, classification problem or regression problem. So you're going to find accuracy, precision, recall, confusion metrics. For regression, mean absolute error, mean squared error, and R2 score. We're going to see this later in the Jupyter notebooks. Next one is the features. So what do we already know about the data, and what features are we going to use? Now, features means different forms of the data. Let's take the previous example, the medical patient records. Now, based on this, you want to do some machine learning, so you're going to try to use these parameters, the body weight, sex, heart rate, chest pain, in order to detect or to predict if someone's gonna have heart disease or not. Now, these parameters are gonna be the feature variables. And the colon heart disease, yes or no, gonna be the target variable. Now, these features can be either numerical, which means numbers like the body weight, heart rate, chest pain, or categorical features, which mean like the sex, male or female, heart disease, yes or no. Now, sometimes you're gonna have also derived features, which means you are the one who's gonna create this one, based on your own data. We call this feature engineering, looking at different features of data and create a new one. For example, visit in the last year. If you have some data on this, you can create this one, or how many visits do you have in last year? Now, these features are related to the structured data, but unstructured data has also features. Now, imagine you have a couple of images of dogs, and you run the machine learning again. You're gonna start detecting a lot of different shapes, maybe 4 legs, 2 eyes. These are gonna be the features used by the machine learning are going to do and to train on it in order to do some computer vision problem, maybe object detection or pattern recognition, for example. Now, what feature should you use? And advice here, try always to take features that's gonna cover all your samples. This is very important. Feature coverage is very important. Like if you have, for example, a feature like most eaten food that cover only 10%, it's not worth using it. It's a bad thing. Don't do it. Try always to get the features that cover the whole data. It's very important, or it's gonna give you bad model. You can simplify it like this. Now, the next one is the modeling part. So here, I break it down in 4 parts. First one is the most important concept in machine learning. We call it the 3 sets, or other word, the training, validation, and test splits. Now we're gonna start doing some machine learning. You want your model to perform very well in real world, new data. You need to do this. You need to split your data onto a training split, where you're gonna train your model on it, a validation split where you're gonna tune your model, so improve it, and finally a test split when you're gonna compare on this. Why is it important? Think of it like this. Imagine you are a student and you wanna learn new subject, new course on AI. You're gonna start learning with the course materials. This is gonna correspond to us as the training set. Then you wanna test yourself on practice exams. This is gonna correspond to us as a validation set. And finally, you're gonna pass the final exam. This is gonna be the test sets. Now, if the students here got a good score or good grade, it means that he learned the subject. He knows what he's doing. So this act of adaptation in a machine learning is called generalization. The ability of machine learning model to perform well on data it hasn't seen before. And this is very important. We need our model to be general. This is very important. You need to remember it. Because imagine there is a leak of the final exam. The professor gives them the final exam. They're gonna study only and practice only on the final exam. Everyone's gonna get a good scores, but did they really learn something? Probably not. Probably just memorization. And this is exactly what we're gonna avoid with machine learning models. We wanna avoid memorization. We want something general. We're gonna see later it's called overfitting, but this is a huge problem. We need to avoid it. This is what you need to do the 3 sets. Now, if you take an example of 100 patient records, the training sets is around, we took always around 70–80% for the training. 10–15% for the validation and 10–15% for the test. Now, each part is going to represent to do something. The first one is related to how you're going to choose and train the model. Next one is how you're going to improve the model, tune it. And finally, how you're going to do some model comparison. We're going to start with the first one. How you're going to choose the model based on our problem. What model should we use? Here, in general, it's by experience. It's not a rule. If you are working with structured data, as I said, Excel files, CSV files, or tables, decision trees model, like random forest, XGBoost, CatBoost, tend to be working the best. If you are working with unstructured data, deep learning and transfer learning tends to be working the best. This is not a rule. This is by experience, and it's just in general. You can start using this when you're going to start a project. Start with these models. Now, once you have chosen a model, you need to train it. What does it mean? Let's take the previous examples. Medical patient records. So our feature, as we said, are these parameters. And target variable is called labels also. Now, we call this, when you're going to start doing machine learning, the feature is going to correspond to us to X, and Y going to be the labels, the column that we need to predict. Now, the machine learning model, when you're going to try to start training, is going to try to find the relationship between these two of the type of Y equal H of X. H is going to be representing the model here. And each model has his own way of doing it. Maybe it's a linear model, non-linear model, polynomial. We don't know. You can choose it. A small example here is we can see a linear regression. Our model is going to be a linear function of the type of hypothesis, theta 0 plus theta 1 x, where theta 0 and theta 1 are going to be the parameters of the model. And you're going to fix a cost function, which is here the mean squared error between the observed value and the predicted value by the model. And the goal, when you're going to try to start training, is to minimize this cost function based on the parameter of the model. This is how, a simplified way, how a machine learning is trained. But don't care. We don't care about this. Forget it. Your goal of you is try to minimize time between experiments. And so when you're going to start doing machine learning, you want to test a lot of different models. The problem is going to take you a lot of time sometimes to test a lot of different. So 2 tips here. First one, never start using the whole data. Always start using a subset of the data. If you have, for example, 100,000 samples, take only 10,000 in order to train your model and to test on it. Never start with the whole data. This is a big mistake. Second tips, start always with simple model and then add some complexity. This is how you can test a lot of. So 2 tips, you need to remember this. Start always with a simple model and with a subset. So things to remember. Some models works better than others on different problems. Don't be afraid to try things. It's very important. Don't be afraid. Try. This is not going to cost you anything. Start small and build up, adding some complexity as you need. Okay, the next one. Tune in a model using the validation type. Now, you want to tune your model. You want to improve it. We're going to take the previous examples. You can see here as cooking the chicken for 1 hour at 180 degrees is not as good as cooking it at 200 degrees. This is a simple example how you can tune the oven. Now, when it comes to machine learning, this is similar, same thing. Each model is going to have some parameters. We call these hyperparameters. And you can play with them, change them, adjust them, try a new one, try a lot of things. And maybe it's going to give you a better model. This is how it's called hyperparameters. An example for this, if you take a random forest model, one of its hyperparameters is the number of trees. We can increase it in order to add some complexity. Same thing for neural networks. Hidden layers is considered as a hyperparameter, so you can increase it to add some complexity. This is how you can play and adjust the hyperparameters in order to get the best model. So the things to remember, machine learning models have hyperparameters you can adjust. A model's first results aren't its last. And tuning can take place on training or validation data set. It will depend on the size of your data set, of course. If you don't have enough data, you're gonna do the tuning on the training split. Okay, the next one is model comparison. Now, how will our model perform in the real world? Now, when you're gonna already done the training, tune the model, you wanna test it in real world. How does it perform? Here, you're gonna face two cases. The first one is when your model gonna do very bad on the training split and the test split. Second one is when your model is gonna do very good on the training split and the performance on the test set very bad. What you are looking to is the third one, where the model gonna do performance very good in training and test. Now, these two kind of cases are named under the name of underfitting and overfitting. This is an example of them for regression and classification problem. For the deep learning also, you can see the loss curve functions. What you are looking to is the one in the middle, the optimal fitting. Now, there are a lot of reasons why these problems came. But the most common one, there are two, are data leakage and data mismatch. Data leakage is same previous examples when you're gonna practice using the final exam, which means there is a leak from the test data into the training data. We need to, at all costs, separate the test data from your model. This is a rule. The model should never see the test data. This is why he's doing some overfitting or memorization. Next one is data mismatch. Is when you're gonna train your model on some data and test it on different kind of data. This is why it's happening a lot, the underfitting. Maybe it's also related to the number of epochs. You didn't train your model enough. Now, I put you here some fixes for them. For the underfitting, you can try more advanced models, increase model hyperparameters, reduce the amount of features, and train for longer. Overfitting, collect more data, and try less advanced models. Now, when you finish fixing these problems, you want to compare your models on new real-world data. Now here, it will depend a lot on the goal that you have set in the beginning. Why I'm saying that? Imagine you are looking only for the best performance. You don't care about the time that's gonna take to train your model or the prediction time. The third model is gonna be the best here. Imagine you are looking for something in real time, computer vision, doing something like YOLO algorithm, like to detect object in real time using your phone. The first model is gonna be the best because the prediction time is very small. Imagine you are looking for both. You need to compromise. So the second one is gonna be the best. What I'm saying here is that it's not always the model with the best performance, the best model. You should know this. It will depend on your goal that you have set. Okay, the things to remember, want to avoid overfitting and underfitting. Keep the test set separate at all costs. Compare apples to apples, of course. Train on some similar data and test on similar data. One best performance metric doesn't equal the best model. Okay, next one is the final steps, experimentation. Now, when you're gonna do some machine learning models, build some machine learning model through these different steps, you're gonna notice that it's an iterative process, which means you're gonna start with the first model. It's not gonna give you a good results. Do it again with another model. It's gonna give you a good results. Try another one. It's gonna give you the best and the perfect model. What I mean here is that even in reality, even if you know all these steps and you go through it and all this stuff, when you're gonna start working on real projects, you're gonna face some problems that you didn't expect. And you need to do experimentation. Experimentation is a huge part in machine learning. You need to experiment by yourself in order to find the solution. So it has a very high weight in machine learning project, experimentation. Now, here what you're gonna try to do is building this framework. But for that, we need to match it to some data science and machine learning tools. I put you here how you can do that. Anaconda here, gonna create our environment. And these libraries are gonna consist on each part. For example, if you can match it, the data science workflow here gonna be created using Anaconda and Jupyter notebooks to create the environment of data science. The data analysis part gonna correspond to these libraries, Panda, Matplotlib, NumPy to do this. The machine learning one gonna correspond to these libraries, TensorFlow, PyTorch, Scikit-Learn. In our case today, we're gonna be focusing on Scikit-Learn. Why? Because it's built on NumPy and Matplotlib and Python, of course, has many already inbuilt machine learning models that you can test. Allows us to evaluate our machine learning using different metrics, and it's very well designed API, and it's very useful and very easy to use and to deploy. Now, this is exactly what the Scikit-Learn workflow that we're gonna try to create with our Jupyter notebooks. We're gonna try to get the data ready, which means doing some data wrangling, data cleaning. Then we're gonna try to pick a model that suits our problem. Try to train it, which means fit the model onto the data and make some prediction, evaluate our model, try to improve it through experimentation, and then save and reload our trained model. Here I put you some tips and advice on how you can get help. For example, this is very important, Stack Overflow. When you're gonna start working, Stack Overflow is very important to use. And also the library, of course, the documentation of the library, Scikit-Learn. Now, let's start modeling. So just before I start this, if you can do quick feedback, it's gonna be very useful for our core lab. And thanks a lot. I know that it's a lot to digest. So I think you're gonna take a break, 15 minutes or 10 minutes, and you're gonna go back to do some modeling. Go ahead. Take 15 minutes? 15, huh? It's recording. That's recording. Yeah.
Thank you so much. In 2021, Nobel laureates received Nobel Prize for modeling, physical modeling of the climate change. So can we use this machine learning to solve the problem of climate change?
Okay, let me know. I sit in the back. Any help or anything, let me know. Okay. Hi, everybody. So in the form, there was a problem with the PI. Try to refresh the form. Now you can skip it and it should be fine. But refresh the form. It has to be the email address, but now we change it. It doesn't, you don't require to fill that field. Okay, another thing, by the way, who wants a painless experience? Painless meaning like using the class hub. It should be all of you, of course, but maybe there's some masochists in the room. We don't know. But please, can you send your GitHub user into the collaborative document we have? We have like 70 slots, like 60 slots, as a matter of fact. And if you are in the carpentry's Etherpad, you can write there your user for the GitHub, and we can add you into the list. So it will, the course will just kickstart. Or you can try to run in IBEX, but we don't promise IBEX will not be a stress. In the email you receive, there is a link to the Etherpad. You can enter to the Etherpad and put there either your notes, or you can write your user.
I'm getting forbidden when I try to.
Yes, because this is what I'm saying. You have to send me the user. Yesterday?
Yeah.
Okay, let me add you again. Well, and I'll send the list, because that will happen. If we don't add you, we will add you, then you receive an email confirming, and then you can enter the class hub.
In my list. Yeah, think to join. Yeah, I have in my list.
Did you give the email confirmation? What's the first name? No, from GitHub. You have to receive something from GitHub. Oh, just let me check here. Okay. Oh, no, I have some Twitter name. Okay. No, you have an invitation already. You're Isaac Ryan. Yes. Or email should be from. Search for. Oh, it's in your inbox as a matter of fact. On the GitHub. Yeah. Have it in that. Yeah. Yeah, no, but they don't have access to. Yeah, no. The thing should be that you should have an email. Actually, maybe I'm checking. Yes, he has a little problem right now, but users are already on it. Like, that's easy. All these guys. Okay, I'm going to send right now. Formalis. The new. I'm still waiting for resources. No, he's not finding the GitHub right. Okay, checking.
Hi, morning.
Yeah, come on.
Hi.
He's
Hi.
good. Yeah, all right, doing good. So we put you a list where you can
I'll
add all the users
Yeah.
already.
Yeah, I had like 18 of them. And,
Did you enter in the collaborative document?
no.
Yeah. The guy.
Send him the document, the collaborative one.
Yeah, if I have that, I'll keep refreshing. And
Exactly, yeah.
and,
So send him the collaborative one.
And one
It's
other
great.
thing that I
Yeah.
want to clarify, someone who uses LinkedIn, they click on Jupyter directly.
No. They need to click on begin the course.
So
Yeah.
now most of them, they have a sample default Jupyter. Go to different.
Oh, no way. We need to precise this.
Okay, just do the announcement. So they have to
So
click in begin
for the
course.
first time, they get whatever data.
Exactly, yeah.
As environment. And then later on, after they did this for the first time, from the day they can click on it anytime. But
Okay, but the first one is beginning of the course, yeah.
Do you want to say it or should I
Okay,
say it?
go.
No.
Okay, I'll add those.
Okay, thank you. Yeah, that's it. So after that, you should be able now go to the link of the Jupyter class hub, your email. That's the email embedded you inside of the class hub. Now you have been activated as a list of the users. Now when you click in the class hub, the dot of the first, it should start.
Okay, it's working. Now, in order to get the resources, so the Jupyter notebooks, you have two options, either using IBEX or ClassHub. Apparently, the reservation for IBEX not working for the moment. So you need to go to ClassHub. ClassHub, you need to get a GitHub account and to send the emails to DDA, and they're gonna add you in the list of the ClassHub. But apparently, you don't. Yeah, you shouldn't send it to. There is a shared document. What you call it? Yeah, this one. You should put your name on this list, and you're gonna add you. But in order to get the resources, don't go here. It's in the email, and click on begin the course, not on Jupyter Hub. Begin the course, yeah, in order to use the already created image of the environment. No, you need to sign in into your GitHub account, send the username in the document that is sharing all this stuff, or send it to DDA. He's gonna add you in the list, and then you can do begin the course. Click on the begin course. With IBEX? Apparently, there is. We have already do reservation, but apparently it's not working. I don't know why. I sent you an email yesterday with the whole information on it. You're gonna have the doc share. Sent it yesterday.
Maybe I didn't get it. But I have the confirm registration.
No, not this one.
There is another one yesterday. From home.
From me. So tape Abdelghafour, you're gonna see if it's already received something. Apparently no. You weren't in the list. Did you register?
Yes, I showed you the confirmations.
I need to. This one. Okay, this one. Here, you need to create a GitHub account and then go here. This one. Put your username GitHub. Here. Put your GitHub username. And then what is the?
Wait. Oh, just write it here.
Yeah, write it here, and then go to the. Where is the emails? This one.
This is why we are actually.
To Mac users, and then go here and do begin the course. But you need to put your name in order to add you in the list. Yeah. Yeah, you're not in the list yet. Or did you click on begin the course?
Yeah.
Maybe they didn't add you yet. Same thing?
Yeah, same.
Yeah.
A little bit because it's going to.
Or they're struggling to get. I don't know if it's. They didn't. Yeah, they don't put you in the list.
Accept the invitation.
Did you put your name on the doc share? Yeah.
Yeah. No.
Ah, Capricci. Okay.
Yeah. No. I mean, we are adding you one by one.
Yeah. So it's gonna take some time to add you in the list.
We just need to wait.
Yeah, you just need to wait. He's in charge, so.
غاد روما تحكي مع الاودينس تعطيهم في ظهرك باش تحكي.
Okay. Yeah, put it in the Carpentries doc that I sent it to you. Go to the email. I sent you an email yesterday. Yeah, this one. Go to this one, Carpentries. Put your. I already put your name.
Yeah, but this is my real name, not my email account name.
No. Put your GitHub account here. Go back. Yeah, go down here. Put your GitHub account.
Yeah.
The username, and they're gonna add you in the list. Yeah. Sorry? You want to what? Sorry.
That's what we need. So I
Yeah, go here in the Carpentries. Put your GitHub username here.
Here?
Wait, I will show it in here, and it's gonna be. So just to clarify the thing, go here in the Carpentries, this one, in the email that I've sent you yesterday, and add your GitHub username in the list here. And then they're gonna add you in the class hub. And that way you can begin the course. This is what you need to do for the month. And if everything is working, you're gonna have this Jupyter notebooks working. Tell me.
You have to tell them they have to check their email once they're added or given permission. They'll get an email.
Oh, you get an email? Yeah, so you get an email when you are added in the class hub. Yeah. So you have to click. Okay, I don't know that. Yeah. Yeah. Okay. Yeah, that's it. So you are added in the So you can click on begin the course. It's gonna give you this Jupyter notebooks. So you're not currently authorized. Check with them. They are in charge of this. Yeah.
I can't access GitHub. I guess you're not currently authorized to message.
And did you receive the email that said that you are added in the? I'll check just this with Ronald. Ronald, were you able to get access? Still? Hmm? No one get. It's working for you. Okay, this is good. Good sign. Go to show, just to see if. Okay, requested. I mean, it's kind of working. This is good.
So just make sure they know.
Yeah, they are starting the container network. Okay.
Email.
And then where should they?
Email. The email associated to their GitHub.
Yeah.
And they have to click this.
Like here's the email, I guess.
Yeah.
This one.
Okay.
Have to click join, and then you have to authorize LastHub to allow
Access to your GitHub account.
to your GitHub.
So they didn't receive the same email.
So just tell them check your email because I didn't check.
Yeah, exactly.
Exactly.
Check your emails. This is very important. Like when you are gonna be added in the list, you're gonna receive an email to get Class Hub. You authorize Class Hub to get access to your GitHub account. So just anything. So you are not added in the list yet. No. Did you put your GitHub name in the carpentry? You should.
Yeah.
Sorry. Yeah, it's in the email that I sent yesterday. Yeah.
So maybe just
To them what?
slowly repeat the steps. Like
Yeah, already. Yeah, but I don't have this email. This is why. But I will show them. Yeah. Because you didn't receive the email yet. You are not. Which one?
This one, right?
Ronald, he received this kind of email. Exactly what you need to receive?
No, not that one. There's another one. The list? Maybe they're still adding you. Who's doing that?
Yeah, and Hassan, I think.
We just have to wait because I think they're doing it one by one.
One by one. It's gonna take some time.
Mail about received this one. It says data to your account.
Yeah, this is not the one. You should. Wait. You need to wait. Just wait. Audio in the list. Yeah.
I received an email confirming that the GitHub access was provided.
Which one?
This one. So I got an email here saying third party has been was actually authorized to access your account. This is after I added it, but when I go back and I try to access it, it's still giving me this error.
You give the access to the. Go back to the email that I sent you. Yeah, this is not the same email that everyone is receiving. Maybe this one.
So just log in for GitHub.
Already put your name in the carpentry, is that right?
Correct. I did. And after I put my name, I got this email from it. Do you think it still has?
So this is
something
not
which
the
I was-
correct email. Yeah, you need to wait for another one. That's gonna give you the permission to get
Got it.
access to this one.
All right.
You need to just do it. It's not the right one. Yeah.
So I added my name in the carpentry. What is this now? I should receive an email?
Yeah, you should receive an email
But I
that said
didn't receive an email so far.
because they are adding you
Okay. All right.
adding you in
Okay.
meanwhile, so
Alright.
it's gonna take you some time. Exactly, yeah.
Okay.
You need to wait till you receive an email from GitHub that said that you need some authorization to into the class. Yeah. Was the problem? Like there are a lot of people?
No, it's not because they keep writing in. You cannot follow the instructions. Like they use this user is the last user that you send it to me, and it's the one that is the beginning, and the second one is gonna be here. So
How can I say this?
I'll go through them one by one.
Yeah, try to go. It's gonna take time. Try always to when you add your name, add it at the end of the list, not in the top, because he's struggling adding the. Yeah, this one. Yeah, it's working for you. But you click on begin the course. Yeah, not on Jupyter. Yeah, that's it. So you then you can go here. I will show you. Yeah, it's a Mac. I'm not introduction here. And start this one, introduction. So wait, we're gonna start doing this. So it's working for you, yeah. Okay.
Get the GitHub, when did you get access? What next we should do?
When you put your name in the carpet trees.
I already got the access.
I've already got access. Yeah, go to in here. The email that I've sent you. Sure. I will show.
I already began the course and I got this lab.
Yeah. Go here to Class Hub when you got access.
Yes, I start this began the course and I already there access also. Yes, I got access.
So you're already on the Jupyter now?
Yes.
Okay, that's all right. Perfect. Here you're not because he didn't add you in the list yet. So you still wait. Yeah, you still wait.
Okay.
You're gonna receive an email of GitHub. That's it. That's what you. Yeah. Wait, I will start there.
I got access from GitHub now. I'm able to access it now, but I don't know how to do it.
I mean, if you get the email from, no, you need another email, I think, from GitHub when you're gonna add you. Not this kind of emails. Another one. Yeah, just wait. I sent it to you. Man, start or it's working for the IBEX?
I took the reservation out and the specifications I just asked for 1 GPU.
Show me here what they need to do to get some reservation.
No, isn't without the reservation?
Without the reservation, which GPU did you put?
In yours.
Hmm?
I didn't specify any.
You didn't specify GPU, what you can do. Wait, I take this just to show them this command.
His problem was that it didn't recognize it from some reason, but
it's not.
There was a typo or something. So instead of giving I took out these.
This? What's
even the CV100? I took it out. And leave it like that.
Put control, no, nothing like this?
Like that, yeah.
I need to remove the reservation?
Yes. Which is odd because it exists. Yes. Give me that. Like that.
Yeah, but they need to, yeah. This is another alternative if you can't get access to the class hub. You can use this command, but before that, you need to git clone the repository and then use this command in order to get any GPUs. Just how? The git clone. Just you go here in my GitHub repository. Do this. SSH into your host username using a terminal like this. For example, in my case, it's gonna be my host ID. Your terminal. Just type terminal into your. You are using Windows or MacBook? Windows. Windows. It's another story. Windows. I should. Yeah, it's another story. You need to do WSL to use GitHub and all this stuff. Go for the Windows users. Go for the class hub. It's a better solution. Yeah. Just wait for the to get access. But for the others, you can also always do this. Then use this command. Start or how many people have access to Class Hub? Just raise your hand. How many people have access to the Class Hub? Jupyter Notebook. Okay. Yeah, so he's already in charge to add you in the list. With the GitHub, yeah. So as I said, for MacBook users who didn't get access to the Class Hub, do this. SSH into your host ID, and then put this. You can find this command in my GitHub repository. Then when you get access to this, git clone my repository using this, git clone, and then add the link, HTTPS. That way you're gonna have access to the materials. So you do git clone like this for the Mac users. It's gonna download the materials, and when it's already downloaded, you can ask for the resources using this command. So try this for the Mac users if you don't have access to the Class Hub. If you have already access to IBEX and get the resources, you get the resources or not? Because getting into IBEX, that doesn't mean you have the resources.
Now I can get the resources.
Using this command. You ask for 1 GPU for 3 hours, and you will see if you're gonna get access to it. You did it? Did you get it? Okay. So now, did you have access to the Jupyter notebooks? It's working, yeah. Just take this link, copy the first, let me see. This one, yes, and put it into this one, yeah, and put it into the browser. All All right, it's working.
Same
So,
on this one. Okay, but this.
you have access to class hub.
Yes.
Oh, okay. Yeah, you took like it into one resources for the others, but yeah, you can use the class hub is better. Yeah, and you can cancel the other one. That's another one. Yeah, you're gonna be able to get it. Yeah.
Are we working on fixing the problem, or we will not have access? I use a Windows machine. I still get the forbidden update. I cannot access the GitHub. I cannot access items. Shall I go back to my office, or shall I wait for the resolution?
No. I mean, they're gonna add you in the list. If it's not working, you can follow. I will start the course and you can follow. It's not big deal. Yeah. I will go through the different steps. Yeah, so we can. Yeah.
We received the email. I'm sorry, I did not get instructions how to proceed.
Yeah.
I hear that we should receive. I received an email almost 25 minutes ago, but I still cannot access the GitHub class.
You don't have access.
No, I have no access.
Try to put your name in the bottom of the list. You're gonna maybe. You did already did that. Yeah.
My name first, and then I went again. I got toward the end of the list. I still don't have access to the class.
And do you have like Git? We just need terminal with Git. Show me the. I will show you the other solution. This one.
This is the third-party email.
Right.
This one came.
So this is the email you're talking about.
I think so. Yeah.
Right. So I received.
I don't know if it's exactly this one, but you should receive an email from GitHub. You have access to. Which one?
Now this is.
Yeah, you need to git clone the repository first in order to get access to the run. This file. Yeah, git clone.
I just got another one.
Okay.
This one, right?
This one. This is the right one.
Okay.
Join. You see? So it's in progress.
Sorry, I thought that was.
No, this is the right one. Now join the class hub. And now go back to the email. Where is the email? Yeah, this one. Go to the class hub.
And then
begin the course. Sign in with your GitHub account.
I just received the email. Okay.
You see? No, it's working. Okay.
You guys, I didn't.
Need to wait. But I think it's gonna.
So I'm not sure. I might get cloned, but I'm not sure what's.
No. Git clone the repository that I'll give you. Where is my GitHub account?
But this is Windows, not Mac. Doesn't matter.
You don't have a Git here. No. It's not Git. It's Git. Okay. You're gonna be download and then run the command. This command. Okay. Go to the class hub. The mail address on you and do begin the course. Okay, it's working. All right. And sign in and. Okay, so it's working. So okay, we can start. Yeah. Yeah, I know. This is the. I know. But at some point you need to start. But don't worry. The first part is gonna be like I'm gonna go through the whole Jupyter notebooks by providing you the examples and all this stuff, and you're gonna follow with me. Those who have access to the Jupyter Lab and Jupyter Notebook can execute the code with me, but the others can follow. It's not a big deal. And then you're gonna have exercise when if you have some time to practice. Okay? So don't worry. They're adding you into the list. Okay. So here I'm gonna go through the different steps that you have seen in the presentation using Jupyter Notebooks. So for those who have access, can execute the code with me. Don't try to change if you want to play with the code. And for the others, just wait for to get access. Yeah, they're gonna add you in the list. All right. So here I put you some comments, and this is the workflow that you're gonna try to do with Scikit-Learn. We're gonna go by trying to get the data ready. So we're gonna try to do some data wrangling, data cleaning. We're gonna try to choose the right machine learning estimator, like this. Then we're gonna fit our model into our data, make some prediction, try to evaluate these machine learning models, improve it through experimentation and tuning, and finally saving this model and put it all together in a workflow, in a pipeline. This is what we're gonna try to do now. And we're gonna go through these different steps. All right. So here, first step is just to import some libraries, the most used one, yeah? You don't have access to IBEX, that's it? You don't have, yeah, okay, I understand. For the moment, you can check this with my colleague Didier. He's going to help you with this, but I'm going to try to go through different course. Okay. So the first thing that you need to do is get the data ready, which means do some data cleaning. Now, there are three main steps you will often have to take care. The first one is how you're going to split your data into X and Y, so the features and the labels. The second one is converting non-numerical values, so the categorical features, into numerical values. We call this feature encoding. The third thing is filling which means filling the missing value. We call this imputing. So we're going to try to go through these three steps. First, we're going to take the heart disease CSV problems. It's a CSV file that contains an example of data sets. The file gonna contain some anonymized patient medical records, and whether or not they're gonna have heart disease or not. And this is the different parameters or the different attributes. So that's gonna represent our features in this case. The age, sex, chest pain, you can see it here and you can read the documentary. So, I increase the font. Okay, try this. Maybe. Yeah. Yeah, Zoom, yeah, okay. Is it okay or do I need to? Okay, fine. Now, the first step that we need to do is read the CSV file. To do this, we're going to use Panda libraries. So you have a function called read CSV in order to read our CSV files, which is heart disease. Of course, I didn't show you, but the all materials are here in the Jupyter notebooks. You're going to have the data, the images. So the whole materials are in the Jupyter notebooks in the GitHub repository. If you did well the Git clone, you're going to get all the resources. Okay. So the first thing that you need to do is to read the file and to convert the CSV file into a data frame, Panda read data frame. This is our data. We have the features that we're going to be using in order to predict the target, which is if someone has a heart disease or not, 0 or 1. Okay, first thing, you need to split your data into features and labels. Okay.
I think maybe just sell this first.
Okay. Cell is that something like this, which is going to contain your code. And in order to run it, you have two different options. Either using the play button here, like this. If you don't want to use this, go with Shift and Enter. And it's going to execute your cell. Okay, for everyone? Okay. So the first thing that you need to do is to split our data into X and Y. X to get the features. So here, in order to do this, you can see that you are using the data frame, heart disease, created here with Panda. And we're going to use the function called drop in order to get the target out. And it's going to give you our features, the X variables. Same thing for the labels. We're going to take the column named target, and we're going to put it into Y. So here, we created our X and Y. Next thing is to split this into training and test set. To do this, for example, we're going to use the Scikit-Learn library here, model selection. They have already proposed to us a train test split function that you can use. So it's easy to do. You're going to do X train, X test, Y train, Y test. And you're going to use the X and Y, and you're going to put the test size, which means in this case, 20% to the test set. And you're going to use 80% for the training. This is how you can do, you split your data. Okay, so you can always check the shape of your X multiplied by 0.8 to check if it's really 80% of your data. You can see that it's equivalent, 242. Okay, this is the first step, how you can split your data.
Try to run this code because it's given the error.
Which one?
This one exactly.
Yeah, I already did it.
No, from Scikit-Learn model section.
Did you run? Yeah. I don't know why, but yeah, it's working for the moment. But maybe you can, yeah, you can check with you.
So when you write from selection, for example,
yeah, but we already built our image using, what are you using, iBox or ClassHub? Try importing Scikit-Learn, and then do this. But I think it's going to work for the moment. Okay, now the second step is trying to make sure all your data is numerical, which means you're going to have some attributes we're going to represent categorical features. If we take this data set, for example, the car sales, you're going to have that, it's going to have some attributes like make, the brand, which is going to correspond to the brand, the color, odometer, doors, and price. If we read it, the same thing, we're going to use Panda to do this. We're going to read our files. They're going to correspond to this data frame. So here, we already know that this is going to correspond to our make, color, odometer, doors, to our features. And the price is what we are trying to do. So it's a regression problem. OK, to do this, we're going to try to build quickly a model. And we're going to see if it's going to work. If we take this data, you can see that there are two objects and two integers. The others are integers, so numbers. If we build a model, as we have done like previously, by using the train test split, with 20% for the test, and then we try using a quick random forest, just to test if it's going to work or not. You're going to have this error. Why? It's going to say, couldn't convert string to float. Yeah, exactly. We need to work only with numbers. The machine learning algorithm don't understand categorical features. So for that, what we need to do is to convert or to encode our categorical features, which is here, as you can see, make and color. You agree? So if you see the value account for the make and the color, you can get some information about this, how many Like we have Toyota, Honda, Nissan, BMW. And then for the colors, same thing. We're gonna have white, blue, black, red, green. We need to convert this into numbers. But in this example, there is a tricky feature, which is doors. Here, doors, we all agree it's a number. But in reality, it's representing a category. Category with 3 doors, with 4 and 5. So in reality, it's a number, but we need to change it into numerical, like to encode it in order that understood by the machine learning models. So it's a tricky one. So this is why I told you, like, sometimes you it's not working like you apply and it's you need to like think about it. So this is gonna be like a tricky one. So for that, no, you're gonna convert it into category. It's not gonna be read as a number. It's gonna be read as category. You're gonna see this. If you
We code colors into numbers. So
yeah.
we code millions, maybe infinitely many. The color spectrum, like you know, code discretely certain colors, or just range of colors.
No, I will show you how you can what encoding means. I'm gonna show you. Here, we're gonna use the very known function to do that. It's called one-hot encoder. It's proposed by Scikit-Learn. And as you can see, we're gonna take our categorical features, which are make, color, and doors. We're gonna add this one. And we're gonna create our function, which is called one-hot for the one-hot encoder. And then create transformer using column transform. And we're gonna put our function, which is the one-hot encoder, in order to encode these categorical features. And we're gonna pass, a reminder is passed through the other columns. This gonna allows us to convert our make, like these features, this categorical, into numbers. Now, in reality, what is going on? This is exactly what's going on. Here, we have the different features, Honda, BMW, Toyota, and all these brands. The color, same thing, white, blue, white, a lot of things going on. But in reality, what does the function is, it's called one-hot encoding. Why? Because it's gonna take the color, the red, green, blue, red. This is what your data frame contains as color, 4 colors. It's gonna create 4 columns, and it's gonna put a 1 for the specific color. If you are using, for the first car, red, it's gonna put a 1 in the red column. Same thing for the green. It's gonna put 1 there. And that's how you can convert your features from categorical to numerical. This is what one-hot encoding is doing. Now that we have already converted it using Scikit-Learn, Panda also, I'm giving you another alternative to do this. Panda also did this. So in general, we call this categorical features or dummy variable. It's the same thing. If you see another example, dummy variable, it means categorical variable, categorical features. So Panda do the same thing. You're gonna take your data frame, which is here car sales. This is our data frame, and we need to convert make, color, and doors. We do dummies for dummy variable, and we're gonna use the Panda get dummies, and we're gonna put our features. You're gonna see that it's not gonna work for doors. Here, it creates for the different brand, different columns, and for the different colors, same thing. But for the doors, it didn't work. Why? Because it's considered as a number. If you see the car types, you're gonna see it's considered as an integer. So here, what you need to do before doing this function, you just need to convert it to an object. That's it, that's all. And this time, it's gonna work. You can see that it converted the different features, different categoricals into numbers. Here, what is in true, false is just 0, 1. We don't care about this. It's just 0, 1. Now, if we create our random forest model, for example, you can see that it's going to work because everything is numerical. So the first thing that you need to remember is, first thing is to convert your categorical features. Next step, what if there were missing value? So many machine learning don't gonna work when there are missing value in the data. And to fill them, there are two options. Either by filling them by a number, which in general gonna be using the mean of the column, or by removing them. But removing them, if you have like small data set, it's not a good idea to do this. So we're gonna take this example, car sales extend the missing data value. Here, when you're gonna start reading your file, you can see that there are missing value like not a number, like this one. How to detect them? First thing that you need to do is take in this data frame and check for is an A and do the sum, for example, just to check how many missing value for each category. For the first one, you can see that it's 49, 50, 50, 50, and for the price 50. Now here, as I said, when you're gonna do some filling, you have either filling category features by doing, for example, here, we're gonna put missing for the category features. And for the numbers, we're gonna take the mean of the columns. But before that, I'm gonna give you an advice. Each time you're gonna read like a data frame like this one, the missing value from the target, which is the price here, you need to remove it because you're gonna put a lot of, it's not gonna be, you're gonna put like a lot of introducing many fake labels. We don't want this. So when you're gonna have some missing value for the like for the target variables, get rid of them. We don't want to have fake labels. So the first thing that you need to do is take in a function called drop NA in order to take out all the not number from this column, the price. And if you do this is NA to just check if it's gonna work, you can see that before we have 50 for the price. Now it's 0. So it gets rid of this. And if you check the length of our data set, we lost 50 samples, but it's okay. We don't want to work with fake labels. We're gonna keep the data safe. So here, in order to, the next step is to, how are we gonna fill these 47, 46, 48, this missing value? Here, an important thing, don't use data from the future to fill data from the past. What I mean here is don't use the test set in the training set when you are working this. When you're gonna like split the data here, because as I told you, we wanna avoid memorization. So we wanna avoid that our model sees something from the test data. So imagine you're gonna take the whole data and you take one column and all the missing value, you're gonna put the mean of the whole columns. And then you split your data. What does it mean? If you have missing values in the test data, it's gonna take into account the mean in the whole columns. So in reality, your model gonna work with some data from the tests. That's why it's important to split, then to fill the training set, and then to use what you are already filled, and to transform it into your test data. You're gonna see this. Here, I already split the data into X-train and X-test. For the case where we are like filling it with the missing, we don't care. Like it's not a big deal. We can do this. You can use this one, fill NA, and you put missing as a new category for the missing value. For the X-train, X-test. Here, it's okay. For the color, same thing. We're gonna put a new missing category. For the colon field door, here I mean I put a number. I put 4, for example, for the missing value, 4 doors. But for example, for the last one, which is odometer, we're going to use the mean of the color. But here, as you can see, I separate the X-train and the X-test. So here you can see that I fill in the missing value in the X-train using the mean of only X-train. And same thing for X-test. I didn't take the whole data and the mean of the whole data and put it to replace the missing value. This is very important. So here, if you check the previous one, we have all this missing value. And if you check the new X-train and the new X-test, it's going to say 0, because we already removed all the rows and filled all the missing value. Now, we can build our new model. But before that, keep in mind, you need to fill the missing value, then encode the feature, categorical features, then apply the models and fill it. So this is the steps, always. Here, same thing. We're going to use the same code. So we're going to use the one-hot encoder in order to encode make color doors. And we're going to build our new X-train and new transformed X-test. But here this important one. When you're going to do the transformation for the X-train, you're going to use this transformer into fit transform into your X-test, and then only transform in X-test. Why? Fit transform, this application means that the model gonna learn from this data and then transform it. And we're gonna use what it's already learned for the test data. Imagine we have already, like, we do or directly transfer, fit transform on X, not X-train. That means that it's gonna learn and see some data from the test sets. We don't want this. This is why I'm keep telling you, try always to keep separate the X-test and the X-train. Do the fit transform in X-train and then transform on X-test. That, yeah, you're gonna use what it's already learned. Now we have our new transformed X-train, and we can build our machine learning model, for example, quickly. We don't care for this for the moment. We're going to take a random forest, and it's working. OK, so now we're going to see another way, an alternative, how you can fill the missing data. Here, I'm trying to give you the all alternative, all options that you're going to have. Maybe you want to use Panda to do this, or Scikit-Learn. This is what you like. This is exactly what you want to like, or something like this. So here, in order to do exactly the same thing, using Scikit-Learn, they are proposing simple imputer in order to do the imputation. So the same thing, we're going to take the same data. We're going to drop the missing value for the price. Then next step, split the area. Next one is fill in the value before encoding the features, the categorical features. In order to do that, Scikit-Learn proposes simple imputer, which means you're going to create 3 categories, for example, category to fill it with missing. This is for the categorical features. Door imputer in order to fill it with the number, which is here 4 for the doors. And another imputer to do the strategy mean in order to calculate the mean of the columns. Yeah.
The value.
Which? Yeah. Here? This one? Yeah, but I mean, this is not important here. The algorithm can understand this. It's gonna work. Like if you can check it, it's gonna work and it's gonna work. The strategy here constant mean either a number or a string, anything, yeah. It's just a constant, yeah, a value, a number or, yeah, a categorical feature, exactly. It's not meant for numbers, yeah. It can be a number, like this one. Yeah, exactly, it's a value, yeah. We don't care like, hey, it's string, number, yeah. The algorithm gonna understand this. So here we fill the door with 4, the others with missing, and the odometer with mean. So here we're gonna create our features. The categorical one are make and color. The door features is a tricky one, so we're gonna keep it alone. And then numerical features, which are odometer here in our case. And then we're gonna apply the colon transform that's gonna apply this function, simple imputer, for the categorical features in order to put some missing on the missing value. The door feature, we're gonna apply the door imputer into the door feature, and then the num imputer into the odometer, which is the numerical feature here. And then we can build our model by doing some fit transform and then transform. And we have the new field X-train. This is another way to do it with Scikit-Learn. I'm giving you here all the options. Now, if you're gonna check, you're gonna see that there is no missing value again, compared to the original one. Okay, so here, next step, when you fill your data, you need to convert the categorical features. This is gonna be using one-hot encoding as previously. And it's giving you like this 12 columns, because as I said, one-hot encoding gonna be taking the categories. If you have 4 colors, it's gonna create 4 columns, and you're gonna put 1 on each one. This is why you're gonna have 12 columns here. Let's go. Okay, then if we test our model, it's gonna work. All right. So for the moment, we have seen that how we can split the data, how we can encode the categorical features, and how we can fill the missing value. Now, there is another one, which we call feature scaling. It's important. This is important also. For example, say you are trying to predict the sale price of the cars, and the number of kilometers of their odometer varies from 6,000 to 300,000. Now, the median previous repair cost varies from 100 to 1,000. Here, a machine learning gonna have trouble finding patterns in this, because there is a wide range of variables. It changes a lot from columns to columns. So we need to do some feature scaling, which means you have 2 options. Either by doing normalization, so you're gonna rescale your data between 0 and 1, or standardization, when you're gonna subtract the mean of the value. And there's a couple of things to note. Feature scaling usually isn't required for your target variable, of course. It's not required for the labels. And it's not also required with tree-based models. In general, they can handle these problems. So I put you here some, of course, some documentation if you're gonna check by yourself and read some new information about this. But just to show you how you can use them, we're gonna take, for example, the min-max scalar. Same thing, Scikit-Learn propose either using standardization using standard scalar, or min-max to do the normalization, as you wish. So for this case, we're gonna take our preprocessor and put our function, which is the min-max. We wanna do some normalization for this case. And we're gonna take the X-train and the X-test, always. We're gonna fit and transform on the X-train and then transform in the X-test. We don't want our model to learn anything from the test data. This is what it's very important to always do the fit transform on the X-train and the transform only on the X-test. Now, if you look to our new column, it's gonna be all numerical are between 0 and 1. And the model can be run, of course. You're gonna have some results. Okay, now we have seen how we can do data wrangling, data cleaning. Next step is how you're gonna choose the right estimator. Now, Scikit-Learn proposes a lot of models. And for that, it will depend on the problem that you're gonna work on it. If it's classification problem, regression problem, yeah?
Not 90% output around one, like kind of mass flow rate.
Mass-
Example,
yeah.
if we measure mass flow rate.
Yeah.
in experimental, and you have 90% of the data in number 7 to 8. You have 10% of the data different number. How do you make sure in the training? Because if you train like this, maybe the 10% of the high number will not be included. Then the output will be wrong number or away.
No, what I mean here is that if you have a column which is between 0 and 100, and another column, another feature, which is between 1 and 100,000, it's good to use the feature scaling, because the algorithm is gonna struggle to differentiate between this. This is why it's important to use the feature scaling, to get all data between 0 and 1, for example. This is what I mean by the feature scaling. I don't know if you get it or.
For a single column.
Yeah, a single column.
Yeah, it doesn't. Yeah, it doesn't care. Yeah, it doesn't mean anything. If you have a variation between one column, you can put it between 0 and 1. You divide by the max number of the column that you have, and you're gonna have a new column with between 0 and 1. You can do it, but this is, yeah.
For example, if you have a very few number, like will be around 1, and that's something like 10% of the data will be near to 1, and you have 90% near to 0.1, 0.2. How you make sure when you train it? Because whenever you train it, will give you always close to the lower value.
Yeah, but this is not a kind of problem. Yeah, I see what you're. Yeah, it's not related to this one. Yeah, it's not a kind of problem. You can.
But how I can solve this? Have something like.
I have to think about it. Maybe we're gonna discuss this later. I don't have the function. I don't know if you can have some solution. Yeah, for this kind of same column, you have different.
I mean, he's talking about either the data is biased.
Yeah.
Then doesn't have an information. It doesn't have information about the label or the value.
Yeah.
And that feature doesn't actually help to your training. Or you have a, how it's called, like unbalanced training.
Yeah.
Where you have everything biased, and then for the unbalanced part, you can only engineer new features or try to balance in some way with, feature, how it's called, like
derived feature you can
derived
create.
features.
Yeah, derived feature you can create by your own. Yeah.
Or data augmentation. Or you take out all data that you don't find information. It's about what's the end goal. But the problem is you end up either with a lot of data repetition or with not enough data to go with fancy new models. You will have just enough to go linear regression, maybe. But it depends. There are a lot of different libraries that can do upsampling or undersampling, but it's about the problem at the end of the day.
Yes, exactly. Yeah. But for a moment, yeah, I want to say something. Yeah, for the carpentries, put all your question there, and you're gonna get back for you. Because now I think that with the time, I don't know if you're gonna get. Yeah, I want to go through the whole example that everyone gonna see what's and then for the questions on all this, you can put this on the carpentries. You can see this later. Okay, so as I said, you're gonna find a lot of different problems: classification, regression, and supervised problems. Now, Scikit-Learn gives us a cheat sheet that you can use, which is very useful here, for the 4 main categories here, which is regression, classification, clustering, which is going to correspond to ours to unsupervised learning, and dimensional theory reduction. Now, how are you going to choose the model that you're going to use? it will depend on the problem that you are working on. For example, let's take the first problem, which is a regression problem. Imagine we're going to have this data set, which is California housing, which is going to give us like the price. The goal of the California housing data set is to predict a given district median house value using some features like the median income, the median house age, the average number of the rooms, or the average number of the bedrooms. Now, this is our data set. We wanna predict target variables, which is the price here. So we're gonna use these features in order to predict this one. Now, the first thing that you need to check is the length of your data set. In order to check this, we put length on our diaphragm. You can see that it's 20,000 samples. Now, you go to the cheat sheet and you can see that there is path. You're gonna start from here. Do you have more than 50 samples? Yes. Are you predicting a category? In this case, no. Are you predicting a quantity? Yes. Do you have more than 100,000? No. So you go here. Few features should be important. You are not sure about this. Yeah. Where? Yeah, we have less than 100,000. We have only 20,000 of samples. So you go in this kind, this few features should be important. You don't know, you are not sure. This is not a problem. Go for ridge regression. This is how you can start using this in order to select your model. All right, for that, let's try this. We go to Scikit-Learn, linear model, and we're gonna take our ridge regression. So here, same steps. We have our X and our Y. We drop the target. We create our data set, X and Y. We split our data, X train, X test, Y train, Y test, with 20% for the test and 80% for the training. Okay, now we initiate our model, which is the ridge regression for the moment, because Scikit-Learn advise us to use this one. And we're gonna fit our model to the training data. Here, fit means what I said earlier, the model gonna train, gonna find some relationship between X and Y. By doing a lot of stuff behind this, but we don't care. We're gonna initiate our model, and then we're gonna put some score in order to test it in our X test and Y test, how it's gonna perform. Now, here it gives us a number, which in this case, model score gonna give us the accuracy, or the R2 score here, because it's a regression problems. The most close to 1 is the better. This is what you need to know for the moment. It's use a metric, which is the R2 score. If it's close to 1, you have a good model. 1 is the best. Okay, now we see that we have 0.57. It's not that good. So you are thinking it's not working. So you come back here, and if it's not working, exactly here, you go to ensemble models. Now, ensemble models is like grouping a lot of multiple models together to make a decision. The most common one and useful one is the random forest. So you go through this, and you're gonna test this one, just to check if it's gonna give you a better result or not. So for that, you follow exactly the same step. So you have your X, Y, you split your data, you initiate your random forest regressor. Now, random forest, here, it's called random forest regressor because we are using regression problems. But for classification, they have also another model called random forest classifier. Don't worry, this is just to keep in mind. Now you fit your model into your training data in order to train the model on it. And then you see if it's going to give you a score, a better one. OK, it's running. Shouldn't take that long. OK, it gives you 0.8. Amazing. It's a real boost compared to the other one. This is just to give you an idea how you can pick and choose a model using the Scikit-Learn libraries. Same thing, we're going to do exactly the same thing with the classification problem now. We have the heart disease, our heart disease problem. We want to predict if someone going to have heart disease or not. So this is the target variable, always. We're going to see the length of our data. In this case, it's only 300 samples. OK, what we can get with 300 samples? Same thing. We're going to start. Do we have less than 50 samples? Yes. Are we predicting a category? Yes. Do we have labeled data? Of course, in this case, yes. Less than 100,000? Yes. Go for linear SVC, which means here linear SVM. OK, let's try this. So for this, following the cheat sheet, it said that we're going to use the SVM. For that, Scikit-Learn proposed already a model called linear SVC. This is why it's very used and useful, the Scikit-Learn libraries already have all the models. Now, you're going to do exactly the same steps. We're going to just run in this just in case. So we're going to split our data X and Y. We're going to drop the target, which is the heart disease column, yes or no, which is 1 or 0. We're going to split our data, always, training and test set, taking 20% for the test set, 80% for training. And then we're going to initiate our model, linear SVC, which is the linear SVM. And we're going to fit it in our training data. And then let's see how it performs. Here, because it's the classification problem, the score of the model going to be the accuracy here. So in a regression problem, the default score going to be represented with the metric R2. We're going to see this later. And for the classification problem, it's an accuracy. OK, so straight out of the box, you can see that we have 37% accuracy, which is with 2 class. Are they heart disease or not? It's as good as guessing. It's not that good. Yeah, it's like someone is guessing he has heart disease or not. It's not that good. We don't want this. OK, let's try another one. Go through the different path. Now, SVC is not working. Do we have text data? No. Go for neighbor classifier. OK, we forgot about this. We go already into an ensemble classifier because we know that random forest is going to give you a better result anyway here in this kind of problem. OK, so same thing. Random forest propose another one, which is random forest classifier in this case. So we're going to check this. Same thing. Keep in mind, you need to remember these steps. Always splitting the data, splitting it into training test, initiating the model, feeding the model into the training data set, and then test it in the test set. Amazing. We have 85% accuracy, which is very good. Yeah. Yeah, of course. Yeah, because it's an introduction, so I just give you something that you can understand. Of course, when you're going to start a real project, it's a different story. And I also said that it will depend on the number of the data, size of the data that you're going to have. Here we are talking about different, like small samples. So you can't do the thing that you reset because it's not enough. This is just to give you, this is just an example. It's not a real like data set, a huge data set. But yeah, of course, if you want to use like real data and you have a lot, you need to go through the train validation test. Yeah.
So the exercise the 0.2. You decrease that value. For example, let's say 0.05.
What? Which one?
The test size.
Yeah, of course, yeah.
More accuracy. Our model will be more accurate.
Yeah, of course, because you give it more data. If you give your model more data to train on, it can be, yeah, you're gonna perform better in general, but yeah, it will depend in any case, yeah, of course.
So but the problem here, if you want, if you get to 0.5, then we will like, for example, for 10, 50 people or something, we will just test it for or
Yeah, only 5. Yeah, it's not accurate. This is why we need to do 80% for training and 20 to test. This is why, yeah.
Can you put this question also in the Etherpad?
Yeah, exactly. Yeah. The carpentries.
Yes. The thing here is like the more training data you have, the better your model.
Of course, always.
Always. But then when you try to deploy this into the real world, how does your test data looks like? The model will not know in theory. And then that's the real test. Here you're fine-tuning the model. And to fine-tune a model, something has to be given back. So this is why we define like test as a 20% of the complete data, which is something acceptable. People use 75, 85, 90, depends. But write it into the Etherpad because it's interesting.
I have one question. In the protocol for implementing, executing these models, like there is one step where you drop the labels.
Yeah, the first one,
So,
yeah.
My question is like, drop the labels, like how do you evaluate? Because do you need the labels to do validation to see? To do validation, how accurate the predictions are?
Yeah, this is these steps. You see, here we create our X and the Y. X gonna contain only the features, and the Y, the target variables, the labels. And then based on these, like matrix, and we create our train and test. Okay. But yeah, put your question on the capacities, of course. Yeah, don't worry. So what you have seen here, we have seen how you can choose more for classification or capacities. Yeah.
It's related to this. It's not
Yeah.
outside. X and Y.
Yeah.
You mentioned that it's very important.
Yeah.
Can you please repeat what is X and Y?
Okay. Can I give you? Okay, this one. Look, X gonna be representing these columns. What I'm saying when I said drop the target, is just to create two separate there. These columns, so it's gonna be a matrix, gonna represent the features, which is the X. And this column for the target, gonna represent the labels, the Y. Here we are creating X and Y. We spread this.
So X including all of these.
X is this. I don't know if I can like this, but remove the target. Exactly, yeah.
So all of this matrix will be
X, exactly, our features. And the target is gonna be the label, what we wanna predict, yeah.
This is Y.
This is Y. So you have X and Y. And we're gonna split this into 80% for the training, like this one. I'm giving you an example. If you have only five lines, this is gonna be for the training, yeah, X train and Y train. And this here gonna be X test, Y test. Exactly, it's exactly what you are trying to do when we split in the data. All right, okay.
And this predicting X and Y by just by the number of the matrix, like
The relationship between X and Y. This is the role of the machine learning model. We don't care about this for the moment. He's the one who's gonna try to find some patterns and the relationship between X and Y in order to make some prediction layer. You see? Okay, yeah, because a lot of mathematical details, but for the moment you don't care. Just remember, in order to use machine learning model, in order to make it learn from the training data, you use the model.fit. This is the most important part.
and this model is changing depending on
the model I choose.
Yeah, exactly. Yeah.
And all of these names, it has some like cheat sheet.
Of course. I put you a lot of links here to get, if you want a lot of documentation. Don't worry about that. For example, here, this is what's in linear SVC. You can always go back to the documentation. It's a necessary thing. And for example, here, you have, yeah, I didn't present you this. This is the documentation for our Scikit-Learn that you're gonna use. And for each problem, you can have, for example, for a classification problem, you're gonna have a lot of models, of course, for supervised learning and for unsupervised learning. You see? So you can always get back to this documentation and test different models. But here, what I'm saying is that it's a cheat sheet given by Scikit-Learn to find quick model to test on it. See? But always go back to the documentation of the library. It's important.
Data, you uploaded it by CSV file or how?
Yeah, CSV file. This one. As I told you, all your data are here. It's a CSV file.
And I call it in this.
You call it using a library called Panda, which imported in the beginning of the course. It's a library that's gonna understand what Excel files or CSV files is and convert it into a data frame that it will be understood by a machine learning model. That's all. So, okay. All right. Where were we? Where was we? I don't remember. So, yeah, what about the other models? As I'm telling you, like, go to the documentation and you're gonna have a lot of models that you can experiment on it. Don't worry about that. I put you a lot of link to the documentation. But in general, if you have structured data, as I told you, use ensemble methods like random forest. If you have unstructured data, like text, images, audio files, use deep learning and transfer learning. But this is for the next course. Okay. Now that we have already chosen a model, we're gonna fit it. What does it mean fit? I'm telling you, we're gonna go through the different steps, step by step. We have our model. So in order to train it on the data, we use the fit functions. So other names for X, you're gonna see a lot of examples. It's meant for data, feature variables, features. And for Y, you're gonna see labels, target variables. This is the common names that you're gonna see when you are working on machine learning projects. Now, if it's supervised, for our case, it's supervised. This is how you can do this. I mean, I'm putting you here a lot of same thing in order to get into that, how you're gonna remember it. So we're gonna split, if it's classification problem, we're gonna split the data, X and Y, split it into data set and train set by taking only 20% for the test set. Then we initiate our model, which is the random forest classifier here, and then we fit it. Here, what does it mean? It means that you're gonna try to find some relationship between X train and Y train. And here, the thing that if we are talking about, if you remember in the presentation, the regression problem, you're gonna put some hypothesis in the model if you are working with linear regression problem. So you're gonna use a linear function, and you're gonna try to minimize the cost function, which is the error between your observed data and predicted data. But as I'm telling you, we don't care about this for the moment. For you, what you need to remember, in order to train your model, go ahead and use the fit functions. This is what you need to remember. So fit is for training the model. And then our classifier gonna do some score just to see how it's gonna perform on the test sets. And of course, we have seen that we have got an 85% accuracy. So what's happening here, as I told you, we are calling the method because the machine learner trying to find some patterns between X and Y. And if there is no Y, it's only find the pattern on X, exactly. So here is the X that you are looking for. It's gonna correspond only on this. And the Y gonna correspond to the target, which is 1 or 0. does someone have heart disease or not? Okay. So we have seen this, okay, a lot of time. Fit is to train our model. You can always read this by your own. Now I don't have enough time, so we're gonna keep this. Now that you have trained your model, the next step is to do some prediction, of course. For that, in order to predict, we're gonna use this function. We're gonna take your model, which is CLF here, which stands for classifier, dot predict. And of course, in order to test how it's gonna perform on real world, you need to test it on the test set. For that, you're gonna predict on the X test. It's gonna give you some results, 0 and 1, has a heart disease or not. Now, in order to get these results, what does it mean? It's calculating the accuracy. It means it's gonna see where it's gonna see when you are doing some prediction on X test, and he's gonna compare the results to your true Y tests. And you're gonna see how you find the corresponding between these two. When Y predicts gonna be equal to Y tests. In this case, it's corresponding to 85% accurate. This is the accuracy score. So when a model are using the classifier.score, what he's doing behind this is taking the X test, doing some prediction on it, using the model that you have trained on it, and then compare the results to the Y tests. This is why always we have, when we do this one, classifier score, we give him X test and Y test, because they're gonna do some prediction on the X test, and then compare the results to the Y test to see how well it's gonna perform and give you a score. Okay, so for the moment, how things really works, as I said here, it's gonna do some prediction and it's gonna calculate the mean between Y predict and Y test. But in reality, this is gonna correspond to accuracy score. In reality, what's going on behind this is he's gonna give you some probabilities. In reality, it's not gonna give you direct 0 or 1. You're gonna give you, for the first case, for example, 0.89 for the class 0, which is no heart disease, and gonna give you a probability of 0.11 for the second class, which is 1, which is it has a heart disease. This is what's going on behind this. You're gonna give you some probabilities, and if it's bigger than 0.5, you're gonna send it's the first class. If it's under, it's the second class. You see? So it gives you a reality probabilities. So the first one, as you can see, gonna correspond to 0, because the probability is 89.5%. He's saying that he has no heart disease. It's 0. Here, the second, you can see that it's 1. Why? Because it's bigger than 0.5. Same thing for here, 0.57, which gonna correspond to the second class. He has a heart disease. This is what's going on behind the models when he do some score or prediction. Okay, now this is exactly the same thing. Each number is a property for label. You can see this. It's gonna correspond to a class in our case. Now you can always read where does 0.5 come from. I put you some links into this. Now, okay, we already know how to use a model and to predict. So we're gonna use this to predict on X test. And then we're gonna use some metrics, which here, the mean absolute error, for example, between the prediction that we have made and the Y test, in order to get some scores, metric to measure how perform our model. All right. Now we have seen how to choose a model and how to train it. Next step is how we're gonna evaluate it. Here, you're gonna see the different metrics, the different type of scores that we have. And it's going to correspond each one for different problems. Are we working with a classification problem or a regression problem, for example? Now, there are three different methods for evaluating a model. We can see the score method, which is by default, the one by default using by the model. We have the scoring parameter. These parameters can be passed through methods such as cross-validation and grid search CV. We're going to see this later. It's very important, this one. And yeah, that's it. Yeah, the third one is the scoring also, but standalone, given by the Scikit-Learn. Okay. Let's take a general model to evaluate it. For the first one, if we take the previous examples, always with the heart disease, for example, we're going to build a random classifier. We're going to fit our model to train it. And then we're going to test how it will perform using the classifier score function between X test and Y test, of course, always on the test set. This is by default the accuracy for the classification problems. So as I told you, classification, gonna use by default the accuracy as a given score. And the regression, the R2 score, we're gonna see this. So here it's gonna give us the accuracy, which is 85%. And yeah, a model which predicts everything 100% correct will receive a score of 1, of course. This is what meant for accuracy. If it doesn't get everything correct by, in our case, 85%, it's still better than guessing, of course. Now, the next one gonna be the regression problem. For that, we're gonna use the housing to predict the price of the house. Same thing, we're gonna split the data, fit our model into the training data, and then we're gonna do a score on the test data. Here, it's gonna give you, as I told you, a score which gonna correspond to R2 score. Closer to 1 is the better. You can always check the documentation. I give you here some links to that. Now, the second option that you're gonna have is the scoring parameter. Now, this is important because here, as you can see, it's give you only one number as score when you're gonna try to train your model on the training data set and then test it in the test split. It's gonna give you only one score. But in reality, this is not very accurate. Why? Because here, it took, when you split your data, you are splitting it like randomly. So in reality, you didn't learn and you didn't leverage the whole data. A better solution to do this is using what we call the cross-validation, which meant here, for example, if we take our model and we give him directly X and Y, we call this cross-validation, it's gonna give you an array of different scores, 5 here. What does it mean? In reality, this is exactly what he's doing. The cross-validation is doing. Now, as I told you, you're gonna take, for example, 80% for the training and 20% for the test. But this is not gonna represent the whole data and how the model gonna perform real world for the whole different case. This is a better solution. You give him what we call k-fold cross-validation, which means he's gonna try to split your data into 5, and then each time change the test split and the training in order to have a better vision of your all data. And this is the better option to do when you are scoring and testing your model. Always go for the cross-validation. Now, I'm giving you some explanation of this like here. So here, as I'm telling you, like if you give him already X and Y, and CV gonna correspond to the number of split, which is here 5 cross-validation, so 5 split, you're gonna give you 5 scores. And the better solution is to take the mean of this. And this is really how the model gonna perform. This is the better option. So when we are using like only one split, we have an accuracy of 85. But the mean of the 4 is showing like a little bit down, which is 82. But this is a very, very informative, like this is the very best option that you can get that really explore all data and how a model is performing in reality. It's not performing at 85%, it's performing at 82. This is a reality. This is why you need to go always with the cross-validation. Now, the cross-validation score function, we will use it on X and Y. We give it number of split, maybe 5 by default. It's the used number always. And then you're gonna have a scoring parameter that you can adjust. For that, the default one here, in this case, as you can see, is the accuracy. This is why it's giving you these scores. It's using by default the accuracy. Now, here you can see that there are different metrics that you can use for the classification problems, for example. First one is the accuracy, as we have seen. All right. Second one is what we call the area under the curve, the ROC function. So yeah, this is just a repetition of accuracy, okay? We have hard disk accuracy at 85. Now the next one is area under receiver operator characteristic. We call this the ROC function, or yeah, the ROC function, area under the curve, exactly. And it's gonna give you, yeah? You know, ratio under the curve or area under the curve? I don't know, I remember area under the curve, but you can always check the documentation. But for the moment, what you need to remember is that it's gonna give you a score. We call this AOC, which is area under the curve. It's gonna use some parameters like true positive, false positive, true negative, and false negative. True positive is when the model gonna predict 1, and the truth is 1. False positive is when model gonna predict 1, and the truth is 0. True negative is when the model predicts 0 and it's 0 in reality, and false positive when it predicts 0 and the truth is 1. You're gonna use these parameters in order to calculate what we call here FPR and TPR. It's yeah, false positive rate and something like this. Yeah, exactly. So here we have already a function which called ROC curve in order to calculate this. So we don't care about how to do it. We just need to put the Y test and the Y probabilities. So when you're gonna predict on X text, of course, and you're gonna calculate these ratios. And then you're gonna give you some numbers, but in reality, it's gonna correspond to this graph. I put you here a function to plot the graph. This is what you're gonna get. You're gonna have the ROC, the guessing function, the guessing curve, and in yellow, you're gonna have this parameter, the ROC function. So the perfect model gonna give you a score of 1, which means if you put here, in order to calculate, of course, this AOC, we have already a function to use it, which is the ROC AOC score. So you will put the Y test and the Y probability that you predict using your model. And it's gonna give you a score. Here, it's 93, which corresponds to this area. So if it's a perfect score, it's gonna give you 1, which means this. You're gonna get this kind of graphs, which means here, for example, a ROC curve between Y test and Y test. So reality and reality. This is the best that you can get, of course. It's gonna give you a score of 1, and it's gonna correspond to this graph. So this is another alternative to measure how your model is accurate or how your model is performing on test data. The next one is what we call confusion matrix. It's gonna use exactly the same thing like the false positive, true positive, and all this, in order to create a matrix that's called confusion matrix between Y test and the prediction, of course. So here, it's gonna give you a better look, is this one. Our predicted label, which is 0 and 1, with the actual label. For example, here, it predicted that 24 true and 28 true. And here, false positive and true positive. This is another way to see how your model is performing and the number of samples he get wrong. You get a lot of explanation of this. I put you already the documentation on this also. So Scikit-Learn provides you another function to get this in more visual thing, like new matrix like this one. Bear want to visualize the confusion matrix, but this is just to get an idea about the different sample where he got wrong and he got right. Now, the final one is called classification report. This is the best one in my case, in my opinion, for example. You're gonna group you all the different metrics, like accuracy, F1 score, and macro average support, all this, precision, recall. I put you here. So this is how you can get this, always by using already predefined function given by Scikit-Learn, which is called classification report, and always by giving him the Y test and the X test, then the Y predict of the prediction, of course. I put you all the definition of all this. You can go through this, and if you wanna learn more about these metrics, but this one is the best for me because it's gonna give you a good idea about how your model is performing. Now, there is another thing that, but why precision and recall is very important? Because if you are looking only on accuracy when you're gonna test your model, you're gonna, like, I don't want to care about the others. I just look to the accuracy. It's 90%, it's perfect. This is not good. Why? Because if you have unbalanced data, it's gonna give you a huge problem. Imagine, for example, let's say there were 10,000 people and one of them had a disease. Now, you're asked to build a model to predict this. You build a model, and your model is giving you 99.99% like accurate. You are like, all right, now I'm having a perfect model, which sounds great, but until you realize that all it's doing is predicting no one has a disease. And in other words, all 10,000 predictions are false, which is not what you are looking to. This is why recall and precision are very useful, because it's going to give you here, if you look to classification problem using this kind of problem like the 10,000, you can see that the accuracy is 99%. But when you look to the precision and the recall, you're going to see for the class 0, which is no one has heart disease, it's 99%. But for the class 1, it's 0, which is very bad. So this is why it's very important to look to the other metrics and not like tending to use only accuracy. This is not good. This is why classification report is very important to have. Yeah. The next one is the regression matrix. Now, I'm gonna try to go through this quickly because we don't have the time. Same thing, we have some different metrics. The most used one is the R2 score. I give you the definition of them, of all them. Then you have the mean absolute error, the mean squared error. This is the most used one. Same thing, we're gonna build our model, feed it to our trained data, and then by default, our model gonna use the R2 score. So the most close to 1 is the bear. This is what you need to remember. Same thing, you can also, if you put, because it's calculating in general, compare it to the mean. So if you put the R2 score between Y test and the Y test mean, it's gonna give you 0. Because it's compare this to the mean of the data, but don't care or don't wanna care about this. Just remember the close to 1 is the bear. Next thing is the mean absolute error. I give you all the, I'm gonna try to go fast on this just to give you the whole steps before the end of the course. This is just a different kind of metrics that you can find. Mean absolute error, mean squared error. I'm giving you all the code that you can test this. This is just to see the variation between the actual value and the prediction. A good graph to have. Same thing, mean squared error. I mean, all these functions are given by Scikit-Learn, so don't worry. It's already saved functions that you can just call and apply between. No. Always use all of them. Always. Yeah, all of them, all of them. Always keep, yeah, an eye on all of them, exactly. Don't be like only focus on R2 score, for example, for regression problem, on accuracy. No, use all of them just to have a better idea about how your model is really performing, always. So this is the different kind of features that you can use. Now that you have seen this, you can see that, yeah, I was talking about scoring parameter, which means that you can combine these different metrics with the one using the cross validation that I told you previously. So if we take our heart disease problem, we're going to build our random forest classifier, and then we are tempted to do some cross validation score between X and Y. Now, as I said, the default one is the accuracy for the classification problem. But now that we know that it can be combined with different scoring method, you can change this in the cross validation function by giving him the name of the scoring that you want. And now you can do cross validation using a different metrics, which is great. This is exactly what we want to do. So here, it's going to give you the mean of the 5 folds of using the accuracy matrix. Same thing for the precision. You can do a cross validation between X and Y by splitting it into 5 folds. And you can give him as scoring method the precision. And it's going to give you the mean. Here, I'm plotting the mean of the cross validation precision. Same thing for the recall. And this is very important because now you have the ability to use the scoring metric using the cross validation, which is the best that give you the best idea about how your model going to perform on your data. So this is the kind of how you can combine this, the F1 score also. Same thing for the regression metrics. Here, I'm going fast because we don't have the time, but just to give you an idea, same thing. You can combine the cross-validation score with the scoring parameters, which is R2, mean absolute error, etc. I'm not going to execute them because it's going to take some time, but this is the idea. This one, it's already run. Okay. Now that you have, yeah, using different metrics, this is another alternative how you can use these metrics using Scikit-Learn. I put you here, you can see it by yourself. I'm not gonna be entering into this, but this is exactly the same thing in order to give you the same results, accuracy, precision, recall, F1 score for the classification. And for the metrics, regression problems, it's gonna give you R2, mean absolute error, and the MSE. There's a code to do this. Now, how can we improve our model prediction through experimentation? This part is related to how you can tune your model. How you can do this? By giving him different hyperparameter, changing the hyperparameter of the model. Let's take an example of random forest classifier, for example. Now, the random forest classifier is going to have some parameters. In order to check these parameters, you go either to the documentation, of course, always go here. I didn't put it. Yeah, the Scikit-Learn one. So you can find it here. Or you do this, classifier dot get the parameters of the model. And this gonna represent the whole parameters that's gonna use our model. And when I'm talking about tuning the model, is playing with these parameters by changing them, giving them other alternatives, just to check which one gonna give you the best model. Now, there's 2 different ways of doing it. Either by using randomized CV and grid search CV. You're gonna see this. This is just to give you, yeah, all right. Yeah, in reality, there is 3. Either by hand also, but this is not a good solution, forget it. So I can always take these parameters, for example, take my model. This is a function just to print, yeah, to print the how my model gonna perform. But this is the idea. Here, you can, for example, what you are looking for is to do train, validation test, and test set. This is how you can do it. this is the method how you can split your data into the 3 sets. I'm giving you this. Now, we're going to do exactly the same thing. Random classifier, fit it to the X-train, and we built a baseline metric, which is giving us a score here, 82%. But yeah, I shuffled the data. So again, I shuffled the data. It means that I randomized the, yeah, okay, it's not, let's forget about this. Now, it's give us a score, which is going to be corresponding to our baseline metrics. What you want to do is playing around the parameters, the hyperparameters. One of the hyperparameters of random forest, as I'm telling you, is the number of estimator that's going to be using. For example, here, I'm going to play with this by hand by putting 800. It's going to give me a score, 88%, just by putting estimator at 100. You see, I improved my models. Now, in reality, the better option is by doing it using 2 functions, either by a randomized search CV or grid search CV, which corresponds, CV here correspond to the cross-validation. So here, we create a dictionary with the different parameters that we want to play with it. For example, here, number of estimator, the max depth of our algorithm, max features, mean sample split, and all this can be found in the documentation. So don't worry. Go into the Scikit-Learn, go to the model, and you're going to find all these parameters that you can choose and play with. Now we're going to do it not by hand. We're going to fix our dictionary with these different parameters that we're going to use to tune our model. How? Using randomized CV, this function. So here, this function, what you're going to do is going to take this dictionary, and it's going to test these parameters.
Yeah, imagine that grid that he showed by hand, all the different combinations that you have to do by hand.
Yeah, it's gonna get, yeah, you're gonna have, I put you the number, it's 360, I think. Yeah, 360 models.
The last one, 1, 2, 4, these are things I choose.
Yeah, exactly.
Yes.
Yeah, it's
You
yeah,
determine
yeah,
what
exactly,
you want to search. Yes.
Yeah.
So I choose the range I want.
Yeah, it's you. Yeah, exactly.
Do we consider every time we run one of these iterations with 5 parameter variables that's optimized, most optimized, that gives you the best results?
I mean, in general, I am saying this. The model by default is giving you the best parameters in general, but you can always check something that you are like thinking that is going to help you in improving your model, and you're going to play with it and play with the range that you like find it's important to play with it, like the number of estimator, you put a lot. But in general, the default one is giving you the best parameters. But it's always good to do some tuning, just checking if sometimes, as you can see, we were able to improve it by just changing the number of estimator. So here you're going to create your dictionary with the different parameters that you can check. If we go through all this, as this is, it's going to take a while, and it's like 360 models that you need to check. This is why I'm telling you that sometimes it's going to take millions of calculation, and it's going to cost you a lot of time. This is very important. So what randomized CV going to do is taking this dictionary, and you're going to put a number of the number of models that you want to test. For example, here, I want to try 20 models. So in this function, you're going to give him the estimator, which is the classifier in our case, the random forest classifier. We're going to give him the parameters that where you can get the range, and that the parameters that you're going to test. So our dictionary grid. And you're going to use, by the way, the cross-validation, which is great. And you're going to put 20. So here what you're going to do, you're going to test 20 models with the cross-validation. 5 is going to give him a total of 100 fits, which means a total of 100 time he's going to train. You can see this. Now we'll execute I didn't execute the grid. All right, now randomized, you can put a number of 20 just to test only 20 models, because we have seen that it's 360 models. It's a lot. Randomized simplify this by giving us randomly, he's gonna take some parameters here, from here, and test only 20 models in a random way, of course. Now, imagine, so it's running, it's gonna take some time. We don't care, so here, we're gonna follow this. He's gonna find a model that's gonna give you the best parameters. Why? Because always when he fits, he's doing the cross-validation. So he's doing the score method all time with the whole parameters. So you're gonna find you the best parameters that give you the best scores. And using these parameters, you can predict on the X test, you're gonna have the new accuracy. Don't know if it's finished. Okay. So we have seen that we got by hand 88%. I don't know if you're gonna get something better randomly. We're gonna see. This is the new best parameters that he find using the grid dictionary. All right, we got some pretty good results, like precision 85, recall 91, which is great, and the score of 90%. Okay, this is great. This is one way of doing some tuning. Another way is going like brute force, like you want to test a whole grid of dictionary, the whole parameters. So you want to test the 360 models in our case. But here I'm not gonna do this. Like it's gonna test the whole parameters in order to detect this. I mean, in this case, you put the grid and you called which is named as grid search CV, not random search CV, randomized search CV. And here you're gonna go through these different parameters one by one. It's gonna create, in this case, I put less parameters, which are gonna correspond to 72%, 72 models. Each time, and each model gonna be tested 5 times, because we are doing cross-validation. Don't forget this. So here, the grid search CV, same thing. You're gonna put the classifier, put the grid, so the dictionary, and then the CV, always, you can put more than 5. And then you let him like doing the fits. In this case, it's gonna correspond to 5 multiplied by 72 candidates, which are the models that you're gonna test, and it's gonna give you 360 fits. I'm not gonna run this, we are out of time, but this is the idea. At the end, you're gonna have some new parameters, a new classifier with the best parameters, and then you can use this to evaluate on y-test and grid search to y-predicts. Now, here, I put you a diaphragm to compare, for example, the different model, the baseline, the classifier, random search, and grid search. Sometimes you're gonna see that even by doing grid search CV or randomized search CV, you're not gonna get better results. Why? As I'm telling you, the default model are already optimized. So it's giving you the best parameters by default. You can always check this. Sometimes you get the better results, but sometimes not. You have 2 options. Either the first one is collecting more data, which always help us. More data are gonna give you more better results, or trying a more advanced model. In our case, we call this XGBoost or CatBoost. Here, I'm giving you an example of one of them, which is the XGBoost classifier. I don't know how you're gonna perform on this, but this is an advanced model from the random forest. It's called XGBoost. All right, it's giving you 85%, but you can always combine this, which is great. this XGBoost model with some cross-validation, which is great. And you can always do some fine-tuning for this advanced model. And sometimes it's going to give you a huge difference between the XGBoost and the base model, like random forest. So this is just to give you an idea that this model exists, which is the XGBoost one. And you can combine it with some grid search AV, like here, by doing some hyperparameter tuning. Always, how I get these numbers and these parameters? Documentation. Always go back to the documentation of the library. Okay, so now you can do this. I can't run this, we are out of time. So what I wanna say, yeah, I'm giving you here some graphs to compare them. At the end, you can see that the XGBoost are performing well in the accuracy, in the precision, not that well, and the recall and the one is performing better. You see, we improved our model just by using advanced model and doing some tuning. Next thing that you need to know before we end this notebook is how to save your model and load it again, because it's very important. Sometimes it's going to take you a lot to do a lot of epochs and iteration to train your model. And sometimes you don't have the resource for that. So you're going to train it for an amount of epochs, maybe 100 epochs. You stop, you save it, and next day you can load it again and train it another time. This is very helpful in order when you don't have the resources and the time. So to do that, you have two methods. I'm putting you here two kind of the methods. The pickle one. So you're going to import this library. It's called pickle, and you're going to put your model here. For example, I already trained up my model, so I can load it. Then it again here. I need to import this just to show you that now I'm loading it again, and then I will test it directly, and it's going to give me the score. So this is very important to save your model each time you train your model. Another different way to doing it is using the library joblib. So I'm giving you here the whole options that you can take. Go ahead and test it by yourself. You have the notebook, so it's great. And the final one, which is the pipeline. Now that we have go through the different steps that consist on creating a real machine learning project, the final step is creating what we call a pipeline. Now, imagine we have this. The car sales extent missing data. You're gonna load the data using the Panda library, and then you can check your data a little bit to see the different type that you have, if there is any missing value or not. And then we're going to create a one-cell code for the whole pipeline. So next time, you're going to use only this cell. It's going to go through the different steps that we have seen, from reading the data, dropping the target variable, then we're going to create some what we call pipeline, different steps where the model is going to go through. So we're going to create our categorical features, and categorical transformer are going to use the pipeline, which is going to be using simple imputer to fill the missing value, and one-hand encoder then to encode. So in single categorical transformer, it's going to do two things: fill in the data and then encoding in one function. Same thing for doors. We're going to put some fill-in value for 4, and same thing for our odometer category. We're going to put the mean of the column, and then we're going to do, for example, some feature scaling for the odometer. And then we're going to create what we call a preprocessor, which is going to go through these different transformers by using the categorical features, which is our column here, and apply this transformer on these categorical features for the first transformers. Same thing, you're gonna use the door feature, the door transformer, and apply it in door feature. This is what you're gonna do, the preprocessor gonna do. And finally, we create what we call a pipeline for our model. So here, I create 2 steps. I want my model to go through the preprocessor, and then using a selected model. So here, if I'm giving him a random forest, what I wanna do here is when I'm giving my model my training data without doing anything, any data cleaning or anything, you're gonna go through these 2 steps, the preprocessor, and then feed my data with a classifier that I'm putting here. The preprocessor is gonna do all these steps, filling the data with the missing values, and also doing the feature encoding. And this is very useful. Why? Because you have in one cell a whole pipeline that you can test, and maybe next time that you have, now we are testing only random forest. Next step is, for example, going through different models. You don't want to do the whole thing again with different models. What you need to do is creating what we call a dictionary with different models like this one. We want to test ridge regression, Bayesian, different XGBoost, random forest, and then using this dictionary, using the pipeline that you have created. And it's going to give you something like this. It's going to do the whole process using different models. And this is going to give you the best model that perform the best here. This is very important when you have a pipeline prepared, a pipeline that you can test with another different models. And what I want to say also, yeah, you can also do some fine tuning on the pipeline using the grid search. So you put, for example, when you take this pipeline, use a random forest, for example, the model, and you know already the parameters that you want to check if it's going to give you a best model or not, you can combine this with the grid search CV. So if you put the model into the grid search CV, it's going to go through the whole pipeline. So doing the preprocessing and filling the data and testing this for 5 times for the cross validation and going through these whole thing. So it's going to give you something very robust and very good to test. The next thing is that, yeah, as I said, you can combine the pipeline with the grid search CV, which is great. And in reality, this is exactly what he's doing. We have the grid search CV, it gives you the estimator, which is the pipeline, and you have the preprocessing. For the categorical, it's gonna do some filling and encoding. For door, we need only to fill the missing value, and for numerical, same thing. We need to fill the missing value with the mean and to do some feature scaling, and then we're gonna fit using a model, in this case, the random forest. And the final thing before I finish, yeah, we have finished, is the stacking and voting model. Now, this is just to give you an idea to have in your mind. When you have different models that performs very well, and these models are different, they're not working as the same. You take random forest and another one, like linear regression or another model. They're not the same. They're not working the same. What you can do in order to get better results is to combine them. Here you have 2 options, either by using stacking method or by using voting method. I'm giving you here a pipeline how to do it. Like you put, for the stacking, you put the different estimator. So the 2 model, the first one is a random forest here, and second one is the XGBoost. And of course, if you go through the different steps, imagine you have a model, you do the tuning, you do the grid search CV, you do all these steps. You make the best model for random forest. And the same thing for XGBoost. Now you can combine them in order to get better results using either the stacking one or voting regressor. You have 2 options. And in reality, this is exactly what he's doing. You're going to combine this one with this one and give you a new model And in general, it's going to give you the best model. Like here, I'm giving you the results for the stacking model and for the voting model. It's going to combine the resistance curve and take it to the next level. These are the final steps that you can test. And yeah, this function is just to give you better results of visualization of your model. And I think, yeah, that's it. That's all for today. I know it's a lot to digest. I didn't have the time to practice, but don't worry. You have already the notebook. You can go back to it. I put a lot of comments on it, so you can do it by your hand again, and you test this. If you want to practice, I put you in the GitHub an exercise, Scikit-Learn exercise. I put you also the solution. Don't worry. You have all the materials. So here, you can practice by yourself. This time, you can do it again by yourself. I put you some indication, and you can test it again by yourself, alone. And that's all for today. That's it. Yeah. Thank you. Thank you a lot. Thank you. Yeah.